Welcome back everyone. In this session we are going to do a demo on how to do PCA. I'm going to make use of this software called Orange, and you can actually download a copy of this. It's actually free, called orange.biolab.si. What we've done previously is just provided some basic introduction to dimensionality reduction as well as PCA introduction. So feel free to download it. What I'm going to do right now is to just demo to you how the Orange works, or rather PCA works using Orange. So this is the canvas. What I have here is the file whereby I download the data that I want to work with. In this case, we are looking at the data set called Wine. We will also be running the actual code like this in the Python or the Jupyter notebook a little later. For now, I just want to give you a flavor of how this works. There are 178 instances, 13 features here, and the actual Wine is the actual categorical target, or the target that we're looking at. There are 3 types, or 1, 2, and 3 here. Now you can also read the data tables. Remember there's 13 features here, so there's it gives you a breakdown of the contents for each, and if you scroll down you can also see a little bit more. Now the important part that we want to look at is PCA. Now with this PCA, when you double click, it brings up this principal components, the number of principal components here, and on this side is the proportion of variance explained by the number of selected number of principal components. For example, if we choose one principal component, let me just drag that across. It's a little bit small. Let me just see if I can open up. Okay, if I choose one principal component, then what it says here is that 36% of the variance has been explained by this first principal component. If I shift it to 2, 55.4. Shift it to 3, 66.5. 4 is 73. 5 components will explain 80% of the variance. So that's really the first line on top here. Then what about these the bottom? The way that you read this is principal component 1 is 36%. On its own, it explains 36% of the variance. The principal component 2 explained 19%, and 11% for the third one, and on it goes. Okay, so that's really how you actually read this chart. And over here, as I drag this, this components or number of components change accordingly. So I just wanted you to see that as I dragged that number change, it also show you the variance cover or explained. And by the way, all of these data has been normalized before the PCA is being applied to it. Okay, so now that we've got this, we look at the data table itself. So remember, our PCA has 2 components. Okay, we selected 2 components. This is a bit squashed. Okay, so let's just put that down this side. And let's have a look at the data table. The data table shows the 2 principal components, and it shows you the alcohol is 0.114 for PC1, principal component 1, and minus 4.84 for principal component 2. And if I dragged it on, you can see that they're all listed this way. Now the only issue is that we find it difficult to read sideways like this, so I did a transpose so that we can actually read it this way. So let's just say I click this, and what you can see is that flavonoid is the most important, followed by phenols, followed by, okay, I don't know what that is. And then in absolute term, non-flavonoid phenols is also very important. You do have to excuse me. Obviously, wine is not my strength, and some of these chemical compounds is a little hard to pronounce. So that's really how you actually look at the PCA and how it transforms the data. And you can obviously look at the scatter plot itself and just to decipher a little bit more. So that's really the actual demonstration part of it. I'd like you to actually download this. I mean, it is free. It's totally up to you. If you don't want to, that's fine as well. But the whole issue is really just to give you an exposure of how this works before we actually go into actually coding ourselves. With that, I'm going to end this lesson. Hopefully you get a real sense of how PCA works. You have 13 features reduced down to 2. Those 2 features could explain, if I remember correctly, 55%. Yes, that's right. And most people, they like to actually select until maybe 80%, right? 5 features explain 80% of the variance. That's pretty good, rather than having all 13 features, which is obviously an issue that gives you an issue in terms of the dimensionality. We usually can work with 2 dimension, no problem. 3 dimension, we start to struggle. Once we have 4, we're lost. We don't know how to actually look at visualize it anymore. So that's why PCA is really powerful. It reduced to something that we can interpret, especially when it's 2 or 3 dimensions. All right, thank you. I hope you enjoyed that. I look forward to seeing you in the next video, where we actually start coding ourselves and start to understand the actual Hawaiian datasets and how to apply PCA as a dimensionality reduction tools. Thank you for watching.